In the last session, we have discussed about the production of styrene from ethyl benzene and the polymer technology briefly. Let us see what we have discussed in the last session and we recap that. Right. Manufacture of styrene, the chemical reactions involved we have seen, right? Alkylation of benzene. The benzene is alkylated with ethylene in presence of aluminum trichloride and ethyl chloride as catalyst to ethyl benzene. The second stage of reaction, the dehydrogenation of ethyl benzene. Ethyl benzene is dehydrogenated in presence of stannous oxide or iron oxide at a temperature of 1500 degree Fahrenheit to styrene and hydrogen is liberated. We also see in the flow diagram. In this flow diagram, the wet benzene is dried and they actually dried to remove the water or moisture content from that, and then it is dropped into alkylator where aluminium trichloride or a mixture of aluminium trichloride and ethylene and ethylene chloride these are actually fed into this where the alkylation of benzene takes place. Alkylate that ethyl benzene thus formed is taken out, treated with 50% sodium hydroxide solution and allowed to settle to separate the castic which is there in excess as a waste, and then it is stripped to separate ethyl benzene from polybenzene. It, the ethyl benzene, which also consists of unreacted benzene. The unreacted benzene is separated in the benzene column from ethyl benzene, which is taken as a bottom product and sent to ethyl benzene column. In this ethyl benzene column, the ethyl benzene is separated from the top and treated with 20% sodium hydroxide solution, and it is dried in a dryer by passing or by percolating through a flake of sodium hydroxide bed to get the dry ethyl benzene. The bottom product from this is actually recycled to the reactor here. Ethyl, dry ethyl benzene thus formed is then actually fed to second stage of reactor where the ethyl benzene is subjected to dehydrogenation process at a temperature of 800 degrees centigrade, and the after dehydrogenation the ethyl benzene which is obtained is actually passed into a quench tower to reduce the temperature, and then it is separated from water which is formed there, and then it is actually fed to a benzene column to separate the unreacted benzene and ethyl benzene for recovery from the styrene. The styrene thus obtained is separated from the ethyl benzene column here at a temperature of 90 degrees centigrade. The ethyl benzene is actually recovered and recycled to the process. The styrene thus obtained as a bottom product is fed to finishing column where traces of other impurities which are present are actually separated and it is cooled to about 10 degrees Celsius temperature in a refrigerator system and styrene is actually obtained here as the bottom product can be polymerized in the same unit or it can be it can be sent to the other polymerization unit for further production of SPR polystyrene styrene butadiene rubber or polystyrene in this separate polymerization unit. This is what we have studied in the last session. In the last session, we also discussed about polymer technology in brief, and we have seen the some of the nomenclature. You'll recall that first one is polymer. Polymer is a large chain molecule having high molecular weight in the range of 10 to the power 3 to 10 to the power 7. These are made of a single unit or a molecule which is repeated several times within the chain structure. That is called as polymer. Second one, monomer. Monomer is a single unit or is the molecule which is repeated in the polymer chain. It is the basic unit which makes a polymer. It is called as monomer. Next, we have seen the thermosetting polymer. These are the polymers which, when heated, decomposes and hence they cannot be reshaped. Such polymers have the cross-linked or branch-linked structure and are called thermosetting polymers. They are generally insoluble in solvent and having good heat resistance quality. Thermosetting polymers include phenol formaldehyde, urea formaldehyde, silicones, and others. Another type of polymer is thermoplastic polymer. In the polymers in which the monomers composed of linear or having moderate branching. They can be melted repeatedly and cast into various shapes and structures. They are soluble in solvent but do not have appreciable thermal resistance property. Vinyl polymers, cellulose derivatives, polythene, polypropylene comes under thermoplastic polymers. We also discussed about the classification of polymers based on physical structures and chemical structures by preparation method depending on physical properties and depending on applications. On the basis of functionality and degree of polymers, the functionality of a monomer or its degree of polymerization determines the final polymer that will be formed due to the combination of monomers. The number of reactive bonds or groups that are available for coupling with will determine whether the monomer will be monofunctional, bifunctional, or trifunctional, or polyfunctional monomers. If monofunctional or unifunctional monomers when a single reactive group is present in the monomer molecule, then it is termed as monofunctional or unifunctional monomer. However, monofunctional groups cannot be propagate a polymer chain. For example, the monomer which contains monomer of acetic acid or carboxylic acid which contains COOH group is a monofunctional monomer, but a polymer cannot be formed by this monomer. To form a polymer from a monomer, it should have at least one single double bond in the monomer structure. Second one is bifunctional. When two reactive groups are present in the monomer molecule, then it is termed as bifunctional monomer. For example, ethylene, propylene, butylene. The polymerization reaction with bifunctional groups occurs when double bond splits to single bond and couple with another double bonded monomer. If the double bond molecules is present, then the polymer would be a like ethylene is polymerized to polyethylene. Propylene is polymerized to polypropylene. Examples of bifunctional monomers which leads to formation of respective polymers. Then trifunctional, when a monomer contains three active groups or reactive group, then it is termed as trifunctional. For example, a benzene ring. It is important to note that the trifunctional polymer may be a mixture of monofunctional and bifunctional structure. For example, the phenol and formaldehyde. Phenol is a monofunctional and formaldehyde is a bifunctional. So it actually forms a trifunctional uh, monomer. Right. So these are the things which we have studied in the last. This session we are going to discuss about classification of polymers on the basis of their physical structure. First one is linear polymer. These polymers have a linear structure. Only bifunctional monomers can form linear polymers. For example, a monomer is having R double bond R structure. This double bond is actually broken and the second monomer is actually added to that so that it produces a dimer. To that dimer, a third monomer is added, then it gives you trimer, and so on. The monomers are going to go on adding to the polymer which is formed, and a long chain is formed. They are generally thermoplastic polymers, and except for very high molecular weight materials, they are soluble solvents. So this is linear polymer. Second one is cross-linked polymers. These polymers have 3D network structure, that is cross-linked structure. Only bifunctional and trifunctional monomers can form cross-linked polymers. Elastomeric properties are generally endowed in polymers having cross-linkage across the linear chains. For example, here R and S are the two monomers which actually forms a polymer. Usually polymer chains are actually laid one over another, and these chains are actually tied together, right, and forms a cross-linked polymer. Thermosetting polymers have high thermal resistance and mechanical strength may be formed if the cross-linkage among the monomer group is extensive. This is about cross-linked polymers. Then branch chain polymers, when there is no cross linkage in a polymer molecule, at branches arise from the parent polymer chain. Then the polymer formed is called as branched chain polymer. This is the branched chain polymer. Here SRRS is the main chain. This main chain is branched into two. That is, you can see there. You can see here. Here one branch of polymer is actually attached to this molecule, and same time here another polymer chain is attached. This polymer chain further it actually branches here like this and so on. A small amount of trifunctional impurities in the bifunctional monomer may cause branching. Branching may create several physical properties in a polymer, such as decrease of solubility in solvent, raise in the softening point, and also the reduction in thermoplastic properties. Yes. Classification of polymer on the basis of chemical reaction. Classification of polymers based on chemical, right? First one is polycondensation reaction. Is an example of polycondensation reaction. It is a stepwise process. Polycondensation process is a stepwise condensation in which monomer reacts by eliminating a small molecules like water, ammonia, formaldehyde, and NaCl in a repetitive manner. Indefinite growth of the polymer occurs at both ends. The condensation reaction terminates when one of the reacting molecule is completely consumed in the polymerization reaction. In general, bifunctional monomers with different functional groups undergo such reactions. On one common example of a condensation polymerization reaction is the esterification reaction. Benzoic acid reacts with ethanol, undergoes condensation reaction to give ethyl benzoate, expelling one molecule of water from it. The polymer formed after the reaction is called as the condensation polymer. Second one step is actually method is addition reaction. These reactions occurs by the formation of rapid chain and no elimination of small molecule occur. Here actually addition reaction takes place. The two monomers actually react and forms a dimer. This dimer, a third monomer is added to this dimer. So we get trimer, and to this trimer another molecule is added, and so that we get polymer, and this reaction goes on propagating until final product terminated. Such reactions generally occur among double bond or triple bonded molecules or oxo ring compounds. Addition reaction can further of three types. The one stepwise reaction, B or two chain reaction, and three ionic reaction. Then homogeneous polymers polymerization. Homogeneous polymerization, only one identical monomer will take part in the polymerization reaction. If only M and N monomers are present, the M monomer will react and forms a separate polymer, and N molecule will or N monomer will react and forms another polymer. You can see this M monomer actually reacts with another M monomer, gives a dimer MM. To this dimer, you third monomer is added, you get trimer MMM. This is structure until a polymer chain of M monomer is resulted. Similarly, if N monomer is there, it also reacts with another monomer, gives dimer. To this dimer, third monomer is added so that it gives trimer. To this trimer, another monomer is added, and this addition goes on until a long chain of polymer is produced. Next, polycondensation polymers. Here, if M and N monomers are present together, the monomer formed are of random type and alternate type. In random type, the monomers are actually united randomly, whereas in the alternate type, the monomers are united alternatively. You can see here in the random type polymer, here M monomers actually randomly united and forms copolymer, whereas in alternate type reactions, the monomers are actually united alternatively to get a polymer, that is polycondensation. Next, we discuss about block polymerization. The block polymerization. In this type, multimer results from straight polymerization coupled together in blocks. Block polymerization ಅಲ್ಲಿ ಈ monomers block ಆಗಿ polymer block ಆಗಿ formation ಆಗ್ತದೆ. We can see these here. M and N are the two monomers take part in the block polymerization. You can see here the MM, this polymer is formed in blockwise and they are actually united together in random. manner and it gives a polymer. Next, you see the graft polymerization. These have a structure which differs from block polymerization and are formed from M and N multimers. Like the structure is this, it will be grafted or branched. The branch of the polymer of N monomer is added to the main chain at different positions. So these are actually grafted or branched polymerization process. Polymerization reaction does not takes in the four steps, that is initiation, propagation, termination, transfer and termination. These are the four steps through which the polymerization reaction takes place. First was, if we bring simply the monomers together, the polymerization does not take place. Requires some initiation. That initiation energy is required for the formation of a polymer. So it is the rate controlling step in the chain addition reaction. This stage is relatively slow and requires energy for breaking and forming the bonds. The energy is supplied as thermal energy or in the form of radiation energy in the form of alpha, beta, gamma rays. However, by using a catalyst, the activation energy required can be lowered. So this is the initiation. Here, a monomer A, n monomers of A, when energy is supplied alpha, beta, gamma or thermal energy, it actually gets initiated. The star mark indicates the initiated monomer. Then propagation. Here, the reaction occurs between the already formed free radicals and an inactive monomer. With low activation energy, there is more probability of reaction or coalition between the monomers. As a result, rapid reaction occurs to chain to attain the given degree of polymerization. So here you can see the how the propagation takes place. Here A is the activated monomer to which a B monomer is added. So then gets activated. When gets activated, the second monomer B actually reacts and forms BB active monomer. To this BB active monomer, third monomer is added so that we get BBB star, that is activated monomer, and this to this activated monomer another monomer is added and it goes on until the polymerization completes. This step is known as propagation. That is propagation of polymer chain will takes place in the propagation step. And last one is second one is chain transfer reaction. Here one radical of multiplying chain terminates and without the loss of any number of free radicals, a new chain begins. These reactions control the degree of polymerization and the rate of branching of the polymer. Branching usually occurs at higher temperature with the reaction of a multimer with a dead chain. followed by lengthening of the branch due to successive monomer addition. You can see this with the monomer, the second one is with the multimer, and with other molecules. You can see how these polymers are formed. The last one is termination, chain termination. A chain terminates with the net loss of one free radical. It may occur by the correlation of growing chain with coupling or disproportionation. However, if a growing chain collides with an initiation radical, undesirable impurities, or the wall of the reaction vessel, then it might also terminate. Termination is stopping of the polymer chain. Right. These are the reactions which can lead to termination of the polymer chain. That is the active. You can see here. This is Bm is the active 2Bm active molecules, and it actually forms a polymer here. Then here would be a active monomer or chain here. Similarly, in this case also, so the activation is actually gets stopped so that the termination of the chain will take place. Right? We'll see some of the MCQs in this one. An example of trifunctional polymer is option polyethylene, B PVC, polyvinyl chloride, C phenol formaldehyde, and D none of these. The right answer is option C, that is phenol formaldehyde. Second, elastomeric properties are generally endowed in dash polymers. Options are linear polymer, B cross-linked polymer, C branch chain polymers, and none of these. Right answer is answer B, that is cross-linked polymer. Next, third question. Example of polycondensation polymer is dash. Option A polyethylene, option B polypropylene, option C nylon, option D polystyrene. Here option C is the right answer, that is nylon. In polycondensation reaction, the one molecule of water or any other molecule will be actually obtained as a byproduct there or expelled from the polymerization reaction. It happens only in nylon. Nylon is a condensation product. Other three are the addition polymerization, formed by the additional polymerization process. Fourth one, styrene butadiene is produced by dash reaction. Homopolymerization, B copolymerization, C block polymerization, and D graft polymerization. Styrene butadiene is actually polymer is formed by the copolymerization process. That is option B is the right answer. Fifth question. The energy required for initiation of the energy required for the initiation of polymerization reaction is supplied by dash. And the options are thermal energy, option B mechanical energy, option C electrical energy, and option D atomic energy. Right answer is option heat, that is thermal energy. Thank you.